Back in 1989, NASA's Voyager 2 became the first spacecraft to visit and photograph the planet Neptune, the eighth planet from the Sun. Nothing has been back since. That's despite Neptune-sized exoplanets, planets orbiting other stars, appearing to be by far the most common. It's also despite the fact that one of its moons, Triton, is now believed to be a captured dwarf planet from the Kuiper Belt. Essentially, it's a Pluto in orbit of Neptune. Should NASA send a mission to explore Neptune and Triton? A proper investigation of an ice giant planet has been high on NASA's wants list for a while. It's possible that the Neptune Odyssey concept mission could get greenlit by the Decadal Survey for Planetary Science and Astrobiology, a report compiled by the National Academy of Sciences that will set out the priorities for NASA for the next 10 years. It will be published on April 19, 2022. Here's why planetary scientists think that, yes, it is time to return to Neptune. Perhaps the most compelling reason to visit Neptune is to closely study its geologically active moon Triton. It's a dark and shivering place, around -391 degrees Fahrenheit / 235 degrees Celsius on its surface, according to Voyager 2, but has almost no visible craters, so its surface must be constantly renewing itself. In short, it's geologically active. It's also potentially an ocean world with liquid water under its icy crust. Voyager 2 saw geysers spewing dark material about 8 kilometers up, something only seen elsewhere on Enceladus at Saturn, and intermittently at Europa at Jupiter. However, Voyager 2 managed only to photograph 40% of Triton's surface. So just like Pluto, Triton is geologically active and may be an ocean world, as well as being a fellow Kuiper Belt object. Triton is also the largest Kuiper Belt object we know of and the only moon in our solar system that's in a retrograde orbit. One of the big open questions we have in our solar system right now is its formation, said Dr. Cindy L. Young, a research physical scientist at NASA Langley Research Center. The way the noble gases are distributed can let us know if the ice giants formed where they are now, or closer in before migrating to their current positions. Noble gases don't chemically bind to other elements, so they're the purest tracers of solar system formation.